Okay, so we're going to discuss grade 10 math, basic grade 10 math, and we're going to start with chapter 1. Chapter 1 is all about what's called linear systems. So I would say the first thing you should do is understand or memorize the three basic formulas for a line. The first one is this: y is equal to mx plus b. It's called the slope intercept, and we'll get more into that, but essentially m is the slope and b is the y-intercept, which is where x is always 0, you will find where it crosses the y-axis at b. Very important formula to memorize. The next one is called the standard formula. By the way, in this one you'll see fractions for slope and fractions for b. In the standard formula, so this one's called the standard, you won't see fractions ever. You'll see something like ax plus by is equal to c. And an example of this, 3x plus 5y is equal to 8. Now, you can rearrange this into the slope formula, and you can also rearrange the slope formula into the standard. So those are two skills you should learn. Let's start with this one. Oh, and there's one other one that's point form, and it comes from the formula of the slope. So you can always figure out a slope of a graph if you have 2 points. So if you have y2 minus y1, and if you have x2, which belongs with the y2 point, minus x1. We'll get more into this, but these are the three essential lines you have to memorize. So that's where slope comes from. And the point form formula comes from the formula for slope, in which you just move this up here. You multiply both sides by x2 minus x1. Just move that up a bit. And you get this formula right here. This is equal to that. And you also won't find the y2 in there often. You'll just find a y point and the x like this. Now, what's it used for? Well, if you know the slope and you have any point, let's say you have the point 2 comma 3, and you know the slope is 5, you can put the 2 on the x1 and the 3 for y1 and the slope for m, and you'll figure out the formula of your line. For instance, 5 times x minus 2 is equal to y minus 3. We expand this 5 on the left side. 5 times x is 5x. 5 times minus 2 is minus 10. And the right side doesn't need the bracket. And if we want to turn this into a slope formula, a slope-intercept formula, we just add 3 to both sides. Add 3 to both sides. And that becomes y is equal to 5x minus, what's minus 10 plus 3? Minus 7. So get good at your plus minus additions and get good at your fractions. So suddenly we have this, and I can rewrite that into the proper format, and we can see that I was able to figure out the formula of this line using 2 points and knowing the slope. The slope is 5 right there, and there's the y-intercept. So this will cross the y-intercept at 0, comma minus 7. And you can also turn this same thing into the standard. So we're going to practice that right now. It's a very important skill to master. So you should try it over and over again. Math is like drawing. It's like sports. Watching somebody do it will not pass you the test. Practicing it over and over again will pass you the test. And it's also like this. Learning is like this. If you devote the time to learn, so here's nothing, but if you devote the time, you'll learn quite a bit, right up to like 70% mark level. But to get to the 80 mark level, you can see that you have to put in almost the same amount of time, and your mark barely goes up. And then you have to put in a lot more time, and your mark barely goes up. That's because if you study a regular amount, 30 minutes a day, you'll get a 70% mark. But to achieve 80 or 90 requires speed. It requires efficiency. It means you have to practice a lot more, and you got to get rid of stress test. But we're going to practice turning this standard slope into this. So how do we do it? Well, obviously I've got to get y all alone, and you have to learn some algebra. So what I like to do is, if I'm trying to get y all alone, I tell the story of y in bed mass order. Okay, so what's happening to y in bed mass order? First, it's being multiplied by 5. and then 3x is added to it. And you treat 3x like a number. 3 times x is some sort of number. Then I got to reverse that story. So this was the first part of the story, and this was the second part. So I got to reverse that story to undo it. And I start with number 2 first, and I do the reverse operation. Divide both sides. Oh, actually, sorry. 3x is added to it. Subtract 3x, both sides. And then divide both sides by 5. Let's see if that works. So I'm going to first subtract 3x from both sides. So if on the left side I subtract 3x, it's obviously going to disappear. And I'm just going to make a bit of room here. And a lot more room. So if I subtract 3x from both sides, it's obviously going to disappear from the left side. And from the right side, so you're going to have 8 minus 3x. So we're left with 5y is equal to, and guess what? When things are being added or divided, or not divided, added or subtracted, you can rearrange them any way you want. This minus is associated with this term, so I can put it all here. And there's always, when you don't see a term, it's always an invisible plus. Since it's clear these are being subtracted, I can rearrange it like this. I just can't separate the 3 from the x. Now I got to follow step 2, which is divide both sides by 5. On the left side, when I divide it by 5, that 5 disappears. And on the right side, you get this weird thing like this. And here's where practicing your fractions help. When you have this, so I'm dividing both sides by 5. There we go. When you have fractions like this, you're allowed to rewrite it like this. Minus 3x over here, plus 8 over here. And then I'm going to just use the same division line under both of them, like that. I don't know why it turned yellow. And you just put a 5 under each. So it's clear, especially if I just separate that x out, that I've now, even though it looks clunky, I have a slope intercept. And in this case, the slope is right in front of x. And the y-intercept is 8 over 5, which means 0, 8 over 5 will be the spot on the graph, or roughly 0, it'll be 1 point, and 3 over 5 is 6, 1.6. So to do that, I put 5 into 8 one time with 3 over 5 left over, and 3 over 5 in your calculator will produce a 0.8. Fractions and decimals are related. You prefer fractions, though, because fractions will be more accurate than irrational decimal or infinite decimals. So there, I've converted that into a slope intercept. So you'll need that skill, how to get y all alone and come up with the slope intercept formula from a standard formula. You'll discover that the reverse process is similar. So let me reverse that and see if we can get back. Because here's another problem that a lot of students have. And I want you to remember the 3 basics. Write them down, or go back and write them down, because that's something you'll have to memorize, and it'll be used over and over again. Here's something a lot of students are flustered by, is when they see a fraction. And they go, how can I get rid of a fraction like that? There we go. I'm going to just convert that and just get rid of the yellow line. Well, when you see a fraction like this, and it's on an equation, I want you to learn something very important. Whatever you do to the left side, so long as you do it to the right side, does not change the equation. So you must learn this or memorize it, because it's true for chemistry too. Whatever you do to the left side of an equation, if you do it to the right side as well, it does not change the equation. So just push this to the right. This is a really important concept used in chemistry and physics. So that means I could do whatever I want. I can multiply the left side by 10 and the right side by 10. and it won't change it. I could even add 5 to this side if I wanted to, and so long as I add 5 to the right side, I have not changed the formula. This can be proven in Desmos, so this is another tool I want you to learn or use, is Desmos calculator. Very useful. And I'll do it right here. Here's a line. It's clear the slope is 2, and sure enough, there's the y-intercept. And I'm going to multiply both sides by, actually I'm just going to add 5 to both sides. And you'll see that the line is the exact same line. Doesn't matter. I could subtract 5 from both sides. So long as I do the same thing to both sides, it never changes. Doesn't matter what you do, so long as you do it equally to both sides. So the question is, how do you get rid of something that has a denominator by 5? Well, here's another thing about fractions. If I have 2 over 3 and I multiply it by 3, the 3's cancel out. I don't even have to multiply it. If you want, 3 times 2 is 6. 6 divided by 3 is 2. But it's much easier to cancel out. When everything's multiplying and dividing, you can cancel out, which means it's 2. And look at that. No more denominator. So that means if I want to get rid of a 5 here, I just have to multiply both sides of the equation by 5. An incredible, useful skill. You should learn it. So I'm going to multiply the left side by 5. And that's pretty easy, right? It's just that. Now, when you multiply something that's being added on the left side, you essentially have to put it in a bracket. You have to put it in a bracket. And that's what you multiply by 5. Or if you want to think of it, you're going to be multiplying each term on the left side that's separated by a plus minus by 5. But I prefer this way because it keeps it straight in your head what's going on. Now you have to learn expansion, which means the 5 has to multiply this term, which is minus 3 over 5, and multiply this term. Well, it's clear all that's going to happen is the 5's are going to cancel with this first term, and the 5's are going to cancel with this second term. So I'm left with 5y is equal to minus 3x plus 8. Now, if I want to get it in the standard format, I want all my y values and my x values on the same side. So I add 3x to both sides. It's clear it cancels out on this side. And there. I've converted it back to the standard formula. Notice the standard formula never has any fractions. And the slope-intercept formula never has a number in front of y. These are two things that you should memorize. Now, in Chapter 1, it's all about converting and learning how to manipulate a line. So if we look at 1.1, it's just understanding what a line is. And my recommendation to you is if you want to save as much time as possible, jump right to the questions at the end of your book and start doing them. Now, I would skip the weird word puzzles at first and just work with stuff like this with numbers in it, and then go back and work. Because you will have to interpret things back and forth into words. And at any time in this video, just stop and write down whatever. I would also encourage you at the end of your textbook to go back to the end, and you'll often see this, key concepts. Take a picture of that, print it, or transcribe it by hand if you don't have a printer, into a steady notebook, and then throw some of these questions with the correct method to do them in beside it, and that will be the notebook that you study from. And that way you don't have to dig through 5,000 pages. So an important thing is here that two lines only cross at one spot. And there's only one exception to that. When two lines are parallel, they never cross. Things are parallel when they have the same slope and different y-intercepts. So there's just recommendations, very different phrases. And there's another notebook as well that I like, that I actually prefer to the McGraw one. It's called the Nelson one. And let's see if I have it. I don't know if I have it. Home, recent. There it is. So we're going to go down here. Nelson Allowed 2D textbook. And the reason I like Nelson a little bit more is their summaries are a little bit clearer at the end. So go down to your Nelson at the very end of the chapter, and you'll see a similar summary right there. And you can see that it more or less explains what we need to know. We need to know how to graph a line. We need to know how to write the equations I just went over, and a table of value. Now you might say, what's the table of values? How does a line even work? Let's look at this one right here, because this formula is a little easier to work with than the fractions. Here's how a table of values works. First of all, on a graph called a Cartesian graph, x is always along this line. It's called the independent variable. And y is always up here, and it always depends on what x is. So x is something we always just choose, and y we figure out. So let's have a look, and what I like to do when I'm graphing something is, one, use graph paper. So I'm going to take this paper here, and I'm going to see that I have each individual squares, so I'm going to make every step by one, like that, and I'm going to just take a picture of it, and I'm going to bring it over here. That way my squares are all evenly assigned, and it's going to help me overall, and it's better than the thing I was just doing, right? So there we go. So now I just take my table of values, and this is called a T chart, and I pick whatever x values I want. I like starting with -1, 0, and 1, because they're the easiest one. And then I just take my formula, and wherever I see x, I'm going to put in these values. I'm going to make a little space, and I'm going to put a little bracket here, where this is where x used to be, and always just put a bracket. And then I'm going to put in my values of x. So I'm going to put in 1, right, like that, -1 rather, and I'm just going to solve this now. So I can see I got to go in BEDMAS order, so 3 times -1 is -3, so I'm left with 5y minus 3 is equal to 8. Now I've got to solve for y, so I add 3 to both sides. You can tell the story of y. What's the story of y? He's being multiplied by 5, and then he's having 3 subtracted. So the reverse is add 3 to both sides. I get 11 on the right side, and of course on the left side it always disappears. Another way to look at it is this. You see -3 on the right side, so it's going to become -3 on the left side, so it's going to become +3 on the right side. Now I've got to divide, that becomes 11, and I've got to divide it by 5 now, both sides, and I get y is equal to 11 over 5, which is roughly 2.1/5 is 0.2. So that means right here I would draw a line at -1x and y 2.2, which I can't quite get it just right, but I'm going to just draw it right there. Okay? You want to fill it in, by the way, with a dot. Now let's go on with 0. 0 is a lot easier. So wherever I see the x, remember, I'm going to just put in a 0. And by the way, I should write in y before I get rid of it. And you can usually your teacher will prefer fractions, and she'll start you out where there are no fractions. But you can always do, it's 2 1/5, or you can say 11/5, or you can say 2.2. Okay, but generally speaking, your teacher's probably going to want to see just this fraction right here, because fractions are very accurate. They're the most accurate thing possible. Now, if I plug in 0 in here, it's quite clear. This just disappears. 0 is very easy to do. So then I get 5y is equal to 8. And I just divide it by 5 on both sides. And y is equal to 8 over 5, which is roughly 1.6. Now, your teacher, again, is going to give you easier things than this. But I'm just using this to show you how to do it. And it'll work every time. And finally, we take 1 in here instead. And we substitute it in. As soon as there we go, like that. And you get 5y plus 3 rather, is equal to 8. Subtract 3 on both sides. You get 5y is equal to 5. And then y is equal to 1. So we discover that that one's a nice even one. By the way, I should also go back and mark 0, 1.6, and that's our y-intercept. So 1.6 is roughly there, and again, I don't have the graphs. And then finally 1, 1. Now I actually only needed 2 points, because now I can just take this nice line and draw it straight through there, like that. And you should label your dots, so you would take this like this, and depending on what your teacher wants there, confirm with your teacher. So it's -1, 2.1. I'm not going to label this middle one, but you should. And then this last one over here is 1, 1. Notice that we also discovered the we discovered the y-intercept. It's 1.6 right there, 0, 1.6. So we actually are partially there to figuring out slope, and plus what's 1.6? It was plus 8 over 5. So we could actually figure out convert this just by reconverting it back, and you remember we already did it. It turns out that the slope was 3 over 5, right? 3 over 5. And you can also do that by doing y2 minus y1 over x2 minus x1. But now, here's the thing. Let me just put this into decimals. 5y plus 3x is equal to 8. And notice we got the exact same things that we just got. There's 0, 1.6. There's 0, there's 0, 1.6. There's minus 1, 2.2. And look at that. There's 1, 1. Right? So right there, Desmos was really good, and it's exactly what we drew. So that is how you draw it. So that's another skill set you'll need, and you'll need it no matter what. So going back to this, and just going back to the Nelson book, which I kind of like, graph, which we just did, and an equation. Now you'll also have to go backwards from that graph. You'll have to be, sometimes you'll be given a graph where you can clearly see points. So I'm going to just draw through there. Let's just say, let's go through that and that. Sometimes they're going to give you a graph and they're going to say, figure out what the slope or the formula's graph is. What's clear? You're going to give you really clear points when they do this. There's a y-intercept right there. It's going through 0, 3. Now it's not always going to be this clear. And now let's just pretend I didn't draw it poorly and that it went right through 6, 0. And I drew it kind of poorly. 0. We now have 2 points, and we can assign them. It's good to assign the leftmost point x1, y1, and the rightmost point x2, y2. Let me show you the first we need to figure out slope. So we actually already know most of this formula because we can see that the y-intercept is that. So we really only need to figure out the slope. But let's pretend we don't. Let's pretend we don't. Let's first figure out slope. So slope is going to be always this. y2 minus y1 divided by x2 minus x1. And you just fill in what you have on the left. The only thing I encourage you to do, just be very strict about it, is never put this x1 over by the x2 and never put this x2 over by the x1 because you'll get the reverse sign of your slope. So it's clear that my y2 is 0. So up top I get 0 minus 3. And my x2 is 6 minus 0. Notice the bottom is very easy. And 0 minus 3 is minus 3. And 6 minus 0 at the bottom is 6. So we get a minus 1 over 2 as the slope. Now, let's pretend that I can't see the y-intercept. So there's my slope right there. And I can tell you, because I can see the y-intercept very clearly, slope is always called m, that the formula is going to be this. That's going to be the formula. But let's pretend I couldn't figure that out. I now have the slope. I can also see a very easy 2 points, 6, 0, 0, 3. I can now take this formula, which is the point-intercept formula, and I can use the same values here. So for y1, I'm going to use, I can see it's positive 3. Be careful, because if it was negative 3, it's going to be minus 3. So you've got to use the exact values that are there. And the x1 is clearly 0. It's much easier when I have the y-intercept. It's not always going to be the y-intercept. So I get y minus 3 on the left is equal. Now I got to distribute this. I happen to know that the m is minus a half, so when I multiply by x, it becomes that, and when I multiply by 0, it becomes 0. So it just becomes that. And now I've got to add 3 to both sides. And we can see how easy that was. And I've confirmed the formula. But it would have worked with the 6 as well. It would have worked with the other point. So instead of, let's minus 3 here. Let's do minus 0, y minus 0, and x minus 6. X minus 6. And it's still going to work. And now remember that we've already figured out our m was minus a half. So we can put minus a half right there for m. Okay, y minus 0 is just y. Minus a half times x is minus a half x. And minus a half times minus 6 becomes plus 3. Look at that. It came up with the same formula. And then you can also always go back and say y is equal to negative half plus 3 x. Sorry, negative a half x plus 3. And make sure you don't have the x down at the bottom like this, because it'll look weird. And sure enough, we have the same line we just drew. Desmos is fantastic. Saves you a lot of time. You can even print the screen, put it on Paint or into your Google Charts like this. And then just you can move the formula over with it if you want. And see how it's labeled the points. And now I'll just crop it. And now I can put that right into my Google Chrome notes or whatever. Send it to the teacher. And if she wants it by hand, it's easy enough to do on graph paper. Now let's go back to this and say, clearly this here is really written like this, by the way. You should always have your fractions clear. Notice that negative slopes always created down this ski hill situation. In other words, this is a negative 1.5, and this is a downward ski slope. Upward ski slopes, the slope will always be positive. So always read a graph from left to right on the x-axis. So we're going up the ski hill, which means we have a positive slope. If we're going down the ski hill, it's a negative slope. But how do I convert this into standard? Well, it's the same method. I see a 2 as a denominator. So if I want to get rid of a 2 in a fraction, I multiply both sides by 2. What's 2 times minus a half x? The 2's disappear, and it's minus x. What's 3 times negative a half? It becomes negative a half, or sorry, times 2, plus 6. Now I have to get the x to the other side. What did I do there, by the way? I multiplied 2 times negative a half x plus 3, and I used my expansion rules. 2 times negative a half x, 2 times 3. And I ended up with this. Negative x plus 3. Now I've just got to move x to the other side by adding x to both sides. It disappears. And boom, I've got the standard formula. 2y plus x is equal to 3. And by the way, if I put it in here, I will get the exact same law. Oh, 2x plus y, right? 2y plus x is equal to 3. 2y plus x is equal to 3. So I got to make sure what I did wrong there. So I got to multiply both sides by 2. And this was our formula. Oh, stupid. 2 times 3 is 6. 6. So when you distribute it, oh no, that's not right. Yeah, that is right. So it's not a half up here, because this was how I did it. I had to multiply both sides by 2. So 2 times a half, negative a half is negative 1, and 2 times 3 is 6. So that's just a miss, right? There we go. So now if we go back, but notice that Desmos made it clear to me that I made a mistake. So these are the same line because they are the same formula. Even though I multiplied everything by 2 and rearranged it, they are the exact same formula. So that's a skill you'll need. All right. So if I were you, what I would do, if I really had to save time, is go straight to the back of your test sample and just start doing it. I would skip the wordy ones at first. So when they say find the point of intersection, we'll discuss that. 2 different methods. And when they say what is the solution, that's what they're also looking for, the point of intersection. Let's use these 2 methods, look at these 2 and solve them using 2 methods. One is substitution. So again, the lines can only meet at one point. So when I have this line and this line, they can only meet at one point. And at that point, their y's will be equal to one another. Well, if their y's are equal to the other, then this y is equal to that y, but this y is also equal to that formula, and this y is also equal to that formula, which means this formula will be equal to that formula. And that's a form of substitution. Where we see y over here, we're replacing it with this formula. So you get 3x minus 22. I'm replacing the y in this formula with the formula on the left is equal to 4x minus 29. Now I just have to use my algebra. Now I happen to notice that x is positive over here, so and a larger number, so really I should subtract 3x on this side and 3x on this side. On the left side it disappears, and I'm left with minus 22 is equal to x minus 29. So I should add 29 to both sides now. What's minus 29 plus 29? That's why we did it. It disappears. And minus 22 plus 29, which is bigger? The plus number is bigger, so my result will always be positive. And it's 7. If ever you want to figure out how to do that quickly, this is the bigger number and it's positive, so my result will be positive. And then just take 29 minus 22. Because you're allowed to rearrange this, right? This is the same as this. Much easier to see when it's rearranged, isn't it? So we got x is equal to 7. Well, that's only good for half my equation. Now I know what x is, but I don't know what my y is. Well, you can take any equation, and where I see x, this is a form of substitution as well. I will put in plus 7. So I get y is equal to 3 times 7 minus 22, which is 21, minus 22. Which number's bigger? The negative number. So I'm going to have a negative result. What's 22 minus 21? Negative 1. If you want to break this up, negative 22 is also negative 21 minus 1. That adds up to negative 22. It's clear that 21 minus 21 is 0, and I'm left with minus 1. So that means these two things meet at 7, comma, minus 1. And I can confirm this in Desmos by putting in the line 3x minus 22 here was my first line, and 4x minus 29 is my other line. And let's see. 7 minus 1 it says. Yep. So I can see that these two lines met at x7, y minus 1. So get comfortable with your Desmos and get comfortable with various buttons. For instance, if that's not visible for you, I can squish my y-axis down a little bit. Oh, that didn't do it. So I can squish my x-axis a little bit. Let's see if that did it. No, it's still a little bit scrunched. So I actually want to try minus 22 to 22. A little bit better. It's still tough to see. And you can always just zoom in, and the point that's highlighted will be where they meet. And lines can only meet at one point. All right, well, that's fair enough. By the way, you can also use the next method that we're going to use, which is elimination. These both want to use substitution, by the way. But let's look at elimination. In order to eliminate something, the numbers in front of the y or the x must be the same. Now I can see there's a 4 in front of this x, and there's a 3 in front of the other. But I can also see there's only a 1y and 1y. They're both positive, right? It's positive 1y and positive 1y, which means if I put them underneath each other and I subtract top term minus bottom term, top term minus bottom term, top term, and keep track of your minuses, I will get something interesting. Well, what's y minus y? Well, what's 1 apple minus 1 apple? It's 0. And what's 4x minus 3x? Well, it's clearly 4 apples minus 3 apples is 1 apple. Now, here's the tricky part. What's minus 29 minus 22? Well, whenever you see two symbols beside each other like this that are the same, whether they're plus or minus, they become plus. So, which is the bigger number here? The negative number. So if I want to break it down, negative 7, negative 22. This is the same as negative 29. I can see negative 22 plus 22 is negative 7. So that means that I've got this. X minus 7 is equal to 0. So if I want x to equal, I add 7 to both sides, and I get 0 plus 7 on the right side, which is just 7. And we discovered x in the same method. Now I just plug x into either of those equations, and I can solve it. Doesn't matter which one I take, it'll give me the y of minus 1. So that's called elimination. That's where you have to subtract one line from the other, but it only works when the numbers in front of this match or the numbers in front of x match. Okay? In this case, because they give you y is equal to, they want you to use substitution. But I'm going to do something interesting here. I'm going to rewrite this in a standard format. I'm going to add y, and actually you'll always have the x positive, so it's actually going to be y. 4x minus y is equal to 29. If you don't see how I did that, go rearrange this so the y's on this side and the 29's on that side and see if you get that. It's important to have these skills. So pretend I have this and I have this. So clearly this one's in slope-intercept format and this one's in standard. They don't match. But I can see a y is equal to something here. So I'm going to rewrite this one down here. I'm going to rewrite 4x minus. And where I see y, I'm just going to put y. Like that. And up above, I have a y is equal to something. So I can replace wherever I see y with what I believe it's equal to. This is called substitution, where I know y is equal to something else, so I can replace it in any other equation to solve it. Now, the only problem with this is technically this is a minus 1 in front of it, and it's distributing through each term. So minus 1 times plus 3x is minus 3x, and minus 1 times minus 22 is plus 22 because it's a negative times a negative. They're the same symbol. They become positive. So I get this. Now it's just a matter of solving x. 4x minus x is equal to that. Subtract 22 from both sides. 29 minus 22 is 7. And then you substitute it back into either equation. So you can see that this form of substitution is also very easy to do. What's easier though, when you have it like this, yes, you could subtract it, or you just make one equation equal to the other. When you have y is equal to something and y is equal to something, just make one equation equal to each other, and that's because their y's are equal at that one point where they meet. Therefore, their equations will be equal as well at that one point. So that's easier. So when you have y is equal to something, y is equal to something, just make the two equations meet. If they happen to both have fractions underneath, suppose this had a 4 underneath it, and suppose this one on the right side had a 3 underneath it. Oh, headache, right? Well, what do 4 and 3 have in common? If you're really stuck, you can just multiply them. But it's clear that they both are factors of 12. So I'm going to multiply this right side by 12. This is a fictional line, by the way. It has nothing to do with the line in this question. So it's no longer these questions. And I'm going to multiply the right side, because if I do the same to the left side and the right side, nothing bad can happen. So instead of multiplying 3 times 12, which is 36, and dividing by 4, which is 9, 4 goes into 12 3 times. 3 times 3x is 9x. But that full 12 is still multiplying this negative 22. So we have to figure out what 12 times negative 22 is. It's that. So the problem with this situation is we're dealing with huge numbers, right? So in this one also, 3 goes into 12 4 times, and 4 times 4 is 16x. So we got equal to 16x. And finally, you've got to multiply 12 times negative 29. Whenever you want to make a number negative, you type it in and then press this plus minus sign. And you got that. And now that we've gotten, but notice we no longer have any fractions. We no longer have any fractions. So we successfully got rid of our fractions. So that's what we have to do. Now we just have to we'll bring 9x to this side. So 16 minus 9x is 7x. And we'll bring the 348 to this side. So it'll become negative 264 plus 348. And that's a little bit harder to do, right? But we can divide 348 into 300 plus 48, right? That adds up to 348 still. And then I can even do, well, 300. I'm just going to go down the line so it's clear. 300 can be broken up into 260 plus 40, right? That's pretty clear, isn't it? Well, let's borrow 4 from the 40. That's pretty clear. It's clear now these cancel out. Now we just have to figure out what this is. Well, 30 plus 36 is 30 plus 6. 48 plus 30 is 78. 78 plus 6 is 84. These are good methods to use when you want to learn how to manipulate numbers and not have to use the calculator so much. So then I just have to divide both sides by 7, and we're going to discover this is not going to be quite clean. And oh, it is 12. So we discover these two lines meet when x is 12, and then you would just plug it into either of the original equations or even either of the two manipulated equations, this one or that one, to figure out your y value. So 9 times 12 over here is 90 plus 18, it's 108. And then minus 264 is the same as minus 100 minus 164. So that's 8 minus 164. And it's clear that that's minus 156. So that means when it's 12, it's going to be minus 156. It's going to be a huge number. Let's put in these original equations into Desmos and see if that's where they meet. I might have gotten my y wrong, by the way. So let's see. So one was 4 over 3. Over 3x minus 29. And the other one was 3y is equal to 3 over 4x. Right? 4 over 3x, rather. That's up top. 3 over 4x minus 22. Okay, so to see these graphs, we have to sort of zoom out. And they're way over here. Yeah, so I totally got my y wrong, so I'd have to use that. So we can see that it meets at minus 13. So let's see where I went wrong with my y value. So I got my x value correct, right? 12. So let's just use, I think I did some addition, whatever, wrong here. Let's use the original formula. We'll use this one. And wherever I see x, I'll put in 12. So 12 divided by 4 is 3. 3 times 3 is 9. So I get 9 minus 22. Much clearer now that that is minus 11. So I just had to use the right formula. Technically, it should have worked with the manipulated formula. But I think I forgot. Let's see if I still have it. It should still have worked with this. I just think I multiplied the negative 12 wrong. So we'll do 9x, 9 times 12, minus 240. Yeah, the reason it's not going to work is because that's a multiple of the y. It's not the original y. Yeah. So you have to use the original, the original graph. Let's see, 9x minus 264. Yep. Yeah. So you have to always use the original formula when you're plugging back in to figure out y. So that was my big mistake there. And you might say, why isn't it the same value? Because when I multiply, how I would have had to make this the same is this formula, because I multiplied it by 12, is actually equal to 12y. So that's the mistake that I'm making, because technically when I multiply by 12, the y should have been multiplied by 12. So just always use your original formula to figure out the y, and you'll be fine. There we go. And then just continue through your test. So this, again, right there, the easiest method here would be you have a y is equal to this. Plug it in where you see y. Put a big bracket around your y and put this whole formula in. Then distribute, then solve for x, then take your x value and plug it into your easiest formula to solve. And you might say, well, how come a plus b? Well, a plus b, it's still x plus y. It's just they're making you think in new letters. Same with m and n. It's still x and y. Whenever you're missing two variables and you have two formulas, you can solve it. So you just need a number of formulas for the same number of formulas as missing variables. And you can solve it using substitution, and it's a very useful technique. So let's look at this one, D. What would be a better way to do it than substitution? Because I don't really have y is equal or m is equal to anything. But I notice that my m up top is 3m, and my y and my n is 2. So I'm going to multiply the bottom line by 3. Why am I making it 3? Because I want to match this 3 up here. So I'm going to multiply each term by 3. So I get 3m. What's minus 4n times 3? Minus 12n. What's 8 times 3? 24. So I'm going to keep these formulas on the side. But I'm going to replace this one right here with this. Notice my 3m match. Now I'm going to subtract top from bottom. Top from bottom. But keep track of your minuses. Plus 3m minus plus 3m. What's a minus plus? It's a minus. So 3m minus 3m, 0. Minus 2n minus minus 12n becomes a plus 12n. Minus 2n plus 12n becomes plus 10n. Minus 12 minus 24, they're both minus, so just add their numbers together, 36, and put a minus in front. So I get 10n is equal, 10n is equal to minus 36. Divide both sides by 10, and I get minus 3.6. That means I figured out n. Now I can take any of the equations, preferably the smallest or easiest one, and where I see n, I replace it. You're still like doing substitution when you do that, with minus 3.6. So 4 times that is plus, minus times a minus is a plus. 2.4 and 12, 14.4 is equal to 8. So m is equal to negative 6.4 when I get plus 12 to the other side. Let's see if that's true. If I plug these two into Desmos, they should meet at the coordinates minus 3.6 for n and minus, so we'll make nx and we'll make my, so that Desmos knows what I'm talking about, but it might still work with the m and n. So 3m minus 2n is equal to, what was it equal to? Minus 12. Now, so we're going to make nx and my, because it doesn't recognize them. And then just make sure you make the same thing, so it's going to be y minus 4x is equal to 8. I think it was 8. Yeah. Now, so where it meets, did I make my n's x's? Yes, I did. Where it meets will be minus 3.6x and minus 6.4y. Okay, did I get it right? Minus 3.6x minus 6.4y, because I put y where I saw m and x where I saw, let's see, I put x where I saw n and y where I saw m. So my m's are y's and my n's are x's. Since this is n, this is the same as x, and since this is y, So that's why when I put in Desmos, I see the spot that we found. Substitution works no matter what. If you have two missing variables and two equations, you can solve it. So you just continue through your test. Now they want you to look down below. I want to teach you something else here. See this? That's in standard form. Standard form is very useful for finding the x and the y intercept. This is not what the question's asking. What's the x-intercept? It's when y is 0. When y is 0, this disappears. So the x-intercept for this line is... So that means that 4.5 comma 0 will be where it intercepts the x-axis. What about the y-intercept? Well, that's when x is 0. So that disappears. So when I divide both sides by -3, I get y is equal to -3, which means it crosses the y-axis at 0, comma -3. Very useful, the standard for finding that. And if I put this into Desmos, 2x minus 3y is equal to 9. You will discover, sure enough, oh, what did I just get wrong here? No, I got it right. There's the y-intercept, 0, comma -3, and there's the x-intercept. So the standard form is a really fast and easy way to find the intercepts. So also have that skill. Going back to what the textbook is asking, though, they're asking us to solve, explain why each of the following. Okay, so you've got to prove that this matches that right there. If I multiply this by 3, I get 3y equals 2x minus 9. If I then put the 2x to the other side, or the 3y to the other side, and the minus 9 to the right side, you will get this. So take this, multiply everything by 3, then rearrange it till the x's and the y's are on the same side and the numbers on the other side, and you'll see it matches that. X is equal to -3, y is equal to -5. Where do those cross? -3, -5. They cross right there, right where the point that they told us. Prove that this is equal to this. Okay, well notice there's a 2y here, and there's a 1y here. So let's multiply this by 2. You get 2y is equal to 4x plus 1. So 4x, plus 2 when I multiply everything by 2. So there's the 4x plus 2. And when I subtract the left side by minus 2y, I would get 0. And I'd get minus 2y on the other side. And that's what you'll get. So multiply everything by 2 to see if it matches this. Or better yet, divide everything here by 1. You get 2x minus y plus 2 when you put the y to the other side. Or plus 1 when I divide everything by 2. I get 2x minus y plus 1. And when I add the y to the other side, I get y is equal to 2x plus 1, which is that. So all that's happened is they've changed the multiplication. Same for this one. Notice that the y has a -6 in front of it. So just multiply everything by 6. You get 6y is equal to 4x minus 3. 6y is equal to 4x, minus 3 times 6 is minus 18. So you get 4x minus 18. You got a 6 plus 6y on the other side. When I subtract both sides by 6y, I get this. So we got to practice manipulation more. When they say use the method of elimination to solve, they want you to figure out where these lines cross. So just going back to that, maybe I'll do that by hand just to show you. Because that might have been too much to follow, right? And I'm sure it was. Okay, so let's have a look. They want you to prove that everything in ABC matches these lines. Well, it's clear that this one already matches this one. So I don't have to prove anything there. But I need to prove that this one matches this one, and they don't look alike at all. Except that notice that this one has a fraction. So we're going to use our rule of fractions. What's the denominator? 3. We're going to multiply each term by 3. So you get 3y is equal to 2x minus 9. Now, notice that they have their 2x and 3y on the same side. So I'm going to move my 3y over there. So I'm going to subtract 3y from both sides. And I get 0 is equal to 2x minus 3y is minus 9. Then I'm going to add 9 to both sides. And I get this. And suddenly, even though they're on the opposite side of the equal sign, it doesn't matter. You can flip-flop equal signs. Two people can switch sides on this teeter-totter and it's still balanced. There. Those are the same. So that's what they want you to do. This one just essentially says, do these lines meet at the same spot that these lines meet? And it's clear that they do. And then finally, this one's the only tricky one. And you'll have to notice, okay, I don't see any comparison. But you should say, okay, well, there's a 4x here, and there's a 2x there. Let's try multiplying this whole thing by 2. So 2y, 4x plus 2 is what I'm going to get. 2y is equal to 4x plus 2. I multiply everything by 2. Then notice that everything's on the same side over here. So we're going to bring our 2y to the right side, like that. And we get 0 is equal to 4x plus 2 minus 2y. Now here's a little thing on notation. You always start with your x's in alphabetical order. So 2y and your numbers always last. And lo and behold, even though they're on the opposite sides of the equal sign, they're the same thing, right? Doesn't matter if I put the equals 0 over on this side or not. Okay, they're the same thing. So you've proved that those match. Now we got to prove how does this one match this one? A little trickier, but not really. My thing here is noticing, yeah, I could multiply the y by minus 6, but that's a little bit mean. How do I turn 2/3 into a 4? How do you turn 2/3 into a 4? Well, ignoring the 3, it's clear I have to multiply this by 2 to turn it into a 4. But I have a division by 3, so I should multiply that by 3 and see if this works. 3 goes into 6 2 times, and 2 times 2 is 4. So that means if I multiply everything by 6, I should get this. So I'm going to take this top one. I'm going to multiply each term by 6. So I'm going to get 6y on the left. 6 times 2 is 12, divided by 3 is 4x, but you can just cancel the 3 out. And then 6 times 3 is 18. Now I just got to notice that everything's on one side of the equation, so I just got to subtract 6y to that side. And I get 4x minus 6y minus 18 is equal to 0. And I've just proven that they are equivalent. Because as long as you multiply all terms by the same number, you're not changing the equation. So there you go. That's what I was getting on about there. So here, I'm just going to do one of them to show you, and then you should always practice by doing the same technique. So they want you to use a specific method, elimination, right? So that means you have to make these numbers match. Now I want you to know something. The y's right now match. Instead of subtracting, which is, I know they want you to eliminate, but what happens if I add everything? I want you to try that. Just try it. And you might say, well, how do you know to add? Because these have the same numbers, but the opposite signs. And I always know that if I have 5 apples and I take away 5 apples, I have 0 apples. Let's just play along. What's 3x plus 5x? 8x. What is 2y plus minus 2y? Well, we have two opposite symbols there, which means it becomes a minus, and 2y minus 2y is always 0. So I got essentially plus 0, which is just nothing. And then finally, what's 19 plus 5? 24. Divide both sides by 8, and I get that. Now I take any of these formulas and I substitute 3 in where I see x. So I get 3 times 3, which is 9, plus 2y is equal to 19. Subtract 9 from both sides. And finally, I get divide by 2, both sides, and I get that. Which means these two lines should meet at 3, 5. So to see if that's true, we put one line into decimals. I don't know if I put the right line in there. 19. 3x plus 2y is equal to 19. And then I put the other line into decimals, 5x minus 2y. Was it 5? Yeah. And I just got to see if they meet at 3, 5. And sure enough, they do. Now you might say, how did you know to do that? Well, the secret actually is just look to match the numbers first. And if they're opposite, add them. And if they're the same, subtract them. Subtract top from bottom, top from bottom. Both are elimination. It's just this was so easy to do the way it's set up. But you can do it other ways. I could multiply everything by minus 1 and get them the same, and then subtract them. If you only want to work with one method, that's fine. But, so what happens when I multiply each of these terms by minus 1? I get minus 5x plus 2y minus 5. Now these match. Now I'm going to subtract them because they have the same sign. 3x minus 5x is 8x. 19 minus 5 is 19 plus 5. You get the same answer. It's just a lot easier doing it the way I did it. Each of these are used the same way. I want you to notice that these already match. Right? You got 4x and 4x. So just subtract top and bottom. 4x minus 4x is 0. Minus 3y minus 3y is minus 6y. 15 minus plus 5 is 10. So you now have y is equal to negative, you always put the negative up top, 10 over 6, and simplify that's negative 5 over 3. Now you've got to go back and take any of these equations and substitute it in, and you'll discover that, let's see, minus 5, 20, that x is 4. Put both these equations into Desmos and see if they meet at 4, comma, that would be minus 2.66. And continue on. How do you make this match? Multiply the bottom by 2. How do you make this match? That's a tough one. Yeah, that one I should probably do, because it's not easy to see. Because there's not an easy way to turn the 4 into a 10, or to turn the 3 into 2. One way to do it is say, oh, I can multiply this by 10 and this by 4. So then they'll both be 40. But that's a huge number you're dealing with. 10 is pretty easy to multiply by. 4, yeah, sure, let's do that. If I multiply everything up here by 10, I get 40p minus 20q is equal to 60. If I multiply the bottom line by 4, I get 40p minus 4 minus 12q. And what's 4 times minus 1? Minus 4. Now notice my 40p's match and have the same sign. So I will subtract top and bottom. I get 40p minus 40p. Minus 20q minus 12q is minus 20q plus 12q, which is minus 8q. So minus 8q minus 8q is equal to 60 minus 4 is 60 plus 4, 64. So I have minus 8q is equal to 64. Divide both sides by minus 8, and I get minus 8. Now that I've solved for q, I take the easiest formula up here, and wherever I see q, I put in minus 8. So I get 4p. Minus 2 times minus 8 becomes plus 16. It's equal to 6. 4p is equal to, subtract 16 from both sides. And I discover that p is equal to minus 5 over 2, which is the same as negative 2.5. Depends what your teacher wants. Usually fractions are what teachers want. So you've discovered q and p, and you can always go back and make sure that's true. If I put my values of p and q in here, I should get negative 1 as a result. On the left side, negative 1 should come out. Same with up here. The left side should become 6. And then you just go through and you continue with the tests like this. Solve each linear system, choose whatever method you want. So here you could do substitution. I can, wherever I see y in this equation, I would replace it with this. Here, since these match, I'm just going to add them together because they have the same sign. So when I add these two x's together, I get 6x. These will disappear. And when I add these together, I get 2. So 6x is equal to 2. X is equal to a third. Here I would also use, I noticed that the y's match. There's a 1 in front of this y and a 1 in front of this y, but they have opposite signs. So I'm going to add both lines. 2x plus 4x, 6x. These will disappear when I add them. And minus 6 plus minus 6 is minus 12. So 6x is equal to minus 12. X is equal to minus 2. Then sub in for y. Here's a little tricky. There's not really an easy thing to do here. I would multiply the top by 5 and the bottom line by 6, and then subtract the x values. Which is your preferred method? Mine's always substitution, but I can see where subtraction is easier for people to understand. What are the advantages? Well, when working with fractions, substitution isn't substitution is probably easier to do. And when working with standard format, elimination is easier. When working with the slope-intercept format, substitution is easier to deal with. Triangle lies on Cartesian. Okay, well, stuff like this, if your teacher signs it, I just find this kind of stupid. So you'd have to find where these lines cross and these lines cross, find the coordinate of the vertex of the triangle. Greg works half as many hours as Paul. Okay, so sometimes these word puzzles are, tricks students up because you got to use your imagination. So let's just think in terms of what they're telling us, okay? Gregory works half as many hours per week as Paul. So that means if Paul was working 40, Gregory's working 20. If Paul was working 10, Gregory was working 5. So right there, you can say Gregory is equal to half Paul's hours, right? You can also say, with that same equation, Paul's is equal to 2 times Greg's hours. It's the same equation. Between the two, they work a total of 48. That means when I add Paul's hours, let's just call it Paul, and Greg's hours, I get 48. But I also know that Paul's hours are 2 times, you just choose a dot, Greg's. So now I can use substitution. You can even use, let's use P now, and G, because you're used to. And by the way, you can use X and Y if you want. Just keep their things the same terms. If you made Greg Y up above, you got to make Greg Y down below. So now I have what's obviously an easy substitution, because whenever I see X up here, right, just do it like this. Wherever I see X, I can just substitute 2Y. Right? So what's 2Y plus that? 3Y. What is both sides divided by 3? I get Y is equal to, what is it, 16? Yeah, 16. So now I've just discovered what Y is, but you got to remember that Y is, let's see, Y is Paul, I think. We'll figure it out at the end by verifying. And X is Greg. So you just got to remember that. Now I'm going to take the easiest formula. X is equal to 2Y. And wherever I see Y, I'm going to put 16. And actually right there we can see what's going on. X is equal to 32. So that means that we know that Gregory works half as many hours and 16 is the harder. So that is indeed Greg. So because 16 is half of 32. So that means Greg works 16. And Paul works 32. And that makes sense because they both add up to 48. And it's clear that Paul worked twice as many as Greg. Write an equation. We just did. Write an equation to represent the information. Yeah, we just did. Use the method of substitution. We just did. So you got to sort of stretch your mind, but if you start thinking with pure numbers at first, so if Paul's working 20, Greg's working 10. You can see right away those don't add up to 48. So you could just start fiddling around and say, okay, let's say 26. What's half of 26 at 13? Those add up to 39. So you know it's more and more. And so you could do it like that, but you're not going to be able to answer 1 and 2. But as soon as you realize that Paul is equal to 2 times Greg's hours, and then just say Paul equals Y and Greg equals X, then you'll start getting there. And of course, this is a lot clearer. Both their hours add up to 48. Yeah, you got to stretch you got to realize that math is a lot of, now look at this, endless word puzzles. You got to realize math is imagination. And if you think of it as playing, and you're playing with your mind, you might have a little easier time. Okay, what about this? Let's work on each thing. So physics contest has 30 multiple choice questions. A correct answer gains you 4. So 4 times C. Let's call 4 times correct answer. While a wrong answer loses you -1. -1 wrong. Rowley answered every question. So if we multiply all his questions by 4C and 1W. By the way, how many questions are there? There's total of 30. So that means C, the correct answers, plus the wrong answers must equal 30. There can only be so many correct and wrong answers, then they have to add up to 30. So when we do this, this one up here, we realize that Roland got a score of 55. So we have this, and we have this. Now I want you to notice that there's an invisible 1 in front of both these. Do you notice that there's a -1 in front of the one up above? Let's add their opposite signs, +1, -1. Let's add top and bottom. So 4C plus 1C, 5C. -1W plus 1W, 0. 55 plus 30, 85. We're going to divide 85. We're going to divide both sides by 5. So we get C is equal to 17, right? So if he got 17 correct, we can now go back to this formula and say, well, if he got 17 correct, and we put 17 over here, it's clear that 17 plus wrong is equal to 30. So wrong he got is 13. So right there we know that Roland scored 13 wrong and 17 right. And to confirm this, since you get 4 points for every correct, we can multiply this by 4. We get 3468. And you lose 1 for each wrong, and you got 13. We just have to make sure that this comes out to 55. And it does, because that's what he scored. So we know we've chosen the correct ones. A swimming pool is a rectangle, isn't it? So always draw, especially if you have an imagination. Always draw. What does perimeter mean? Perimeter means if I add up this length and this side and this length and this side, they all add up to 96. But let's use x and y. We'll call the longest terms y and the widths x. How many x's do you see? How many y's do you see? I see 2 y's and 2 x's. That means 2x plus 2y add up. And how did I come up with that? It's x plus y is equal to the perimeter. But that's 2 x's and 2 y's add up to the perimeter, which I've been told is 96. So that's one bit of information. But I've also told the length is 3 longer than twice the width. So the length is y, the length is 3 more, so it's going to be 3 more. Let's then twice the width. Let's work in terms. If the width was 10, the length is going to be 3 more than twice of 10. 2 times 10 is 20, so that means the width would be 23, which is 2 times 10 plus 3, right? So that means to figure out this y, I had to multiply my 10. I had to multiply my 10 by 2 and add 3, which means my y is equal to 2 times my x plus 3. Let's see if that works with 10. Let's try 10 again. So if my width was 10, 2 times 10 plus 3 is indeed 23. So it does work. So you got to think in those terms, and it helps if you just start with some numbers and say, okay, well, it's 2 times the width. What if the width was 10? That would be 20, and it's 3 more than 2 times 10, which is 23. How do I turn that into a formula? Well, I multiplied my width by 2, and then I added 3. Takes a little time, but you'll get there. So that means I have a second formula, and I told you when we have two formulas, which we do, we can solve it. But I want you to notice something. It's probably easier to use substitution here. However, I would be tempted, if I was rusty, to always use elimination. So I'm going to do both methods. So you might say, well, those don't match up. Well, I'm going to put the y on the other side and an equals down below it, because it doesn't matter how I rewrite this equation. And I'm going to notice I have a 2x minus. And you might say, yeah, but my y's no longer match up. You're going to discover it doesn't matter. So I'm going to subtract everything. What's 2x minus 2x? 0. What's 2y plus 2y minus 3? I can't do it, so I'll just rewrite it like that. Then over here, what's 96 minus y? I can't do it, so I'm just going to write it like that. So I'm left with this. So I'm going to get all my y's to the same side. I'm going to add a y to each side. So I get 3y minus 3 is equal to 96. And I'm going to get that 3 to the other side by adding 3 to both sides. And then I'm going to divide by 3. 33 says my y. And I should be able to figure out my x from that. Now I'm going to go back and use another method after we're done. And that's this method, which is if this adds up to this, and my y is 33, 2 times 33 is 66. So 2x plus 2 times 33, because I've discovered my y is 33. Is that? Is that? Subtract 66 from both sides. Is that? Let's make sure. If I multiply x, so apparently my x is 15. If I multiply my x by 2 and add 3, yep, it's 33. If it's 15 plus 33 plus 33, does it add up to 96? Well, 15 plus 15 is 30. 33 plus 33 is 66. And 66 plus 30 is 96. So both work. This is twice the width plus 3, and that all adds up to 96. But let's use another method. What about substitution? Well, I can see my second line is y is equal to something. And here's my first formula. So all I'd have to do is create a big space, and in brackets, and that's the important part, in brackets, wherever I saw y, I would replace it with this entire formula. Because whenever you have something equal to something else, you can replace it. You can substitute it. Now all I have to do is make sure I multiply my 2 times that and my 2 times that. And I get 2x, and you might find this easier, plus 4x plus 6 is equal to 96. Some people don't like substitution, so you get 6x plus 6 is equal to 96. Subtract 6 from both sides, divide by 6, and you get that. And then you just got to go back and plug your 15 into your easiest equation, which is probably the perimeter one, and solve for y. But you're going to discover it's the same thing. You're going to get 15 and 33. And actually that substitution wasn't too bad. Just some people have trouble with this. For instance, here's a good way. If A is equal to B, and B is equal to C, and C is equal to D, and D is equal to E, and E is equal to 5, well, guess what? A is equal to 5, B is equal to 5, C is equal to 5, and D is equal to 5, because we just told you everything's equal to the next thing. Even though it says A is equal to B here, I can say A is equal to 5, because B is equal to C, C is equal to D, D is equal to E, and E is equal to 5. So that's an easy way. You can say, well, of course, that's obvious. But you can do that over. For instance, if E is equal to 2B and C is equal to 2D, 2C and C is equal to 2D, and I'll just stop there because we're going to get a little bit crazy. And finally, D is equal to 200. Well, that means C is equal to 100, and B is equal to 50, and A is equal to 25. So all these connections work because I had 4 unknowns and 4 equations. And I'll let you figure out how I did that one. So on this next question here, keep in mind whatever your teacher assigned you in homework is probably what you're going to have on a test. So we got a restaurant, and it serves a buffet lunch. This looks hard. And it has one price for adults, so A, and another price for children under 12, so C. The young group has 2 adults and 3 children, and their bill was this. So we're trying to figure out the price. So we know that price adults and price children are different. Let's just call it, I hate calling it C and P because we're going to have to throw in some numbers here. Cost adults, or cost adults and cost children. Okay, well anyway, the first group, he has 2 adults, so two of them paid the price for adults, and 3 children paid the children price, and when you add them together, it came to $48.95. Now, when you're working with decimals and you don't want to, you can multiply everything by 100, and you get that, and it still works. Still, you multiply both sides by 100. Just letting you know. But let's go on. The Harvey group, this is a different group, so this is a Young's group, but the Harvey group still has the same fee on the menu. And they had 3 adults, so those 3 adults paid the adult price, and 2 children, and their bill came $52.05. So they want to know what is A and what is C. Well, you've got 2 equations with 2 unknowns. Notice that it's a little bit harder to do elimination because the numbers don't match. And substitution's a big mess. So I'm going to multiply this top line by 3. Why? Because 2 and 3 have 6 in common. So I'm going to try to turn this to a 6 and this to a 6. So I'm going to multiply everything here by 3. So I get 6A plus 6C, 9C, is equal to, here's the tough part. Well, it's better just to take out a calculator. 48.95 times 3. Then you can grab it all like that and copy and paste. Great. So let's just put this original formula aside. Get rid of it. Now I'm going to multiply this one by 2. And I get 6A plus 4C is equal to 104.10. A little bit easier, that one. So this, put aside. Notice I have 6A and 6A, so they match. So they're both the same sign, so I'm going to use a subtraction. So I'm going to subtract top minus bottom. So I get 0. What's 9C minus plus C, 4C, which is 9 minus 4C? It's 5C. So I get 5C. And here I have to use a calculator. So I'm just going to do 5C is equal to 146.85 minus 104.1. And I get that. And now I just got to divide both sides by 5. So now I've discovered that the children's menu costs $8.55. I just got to use either of my simpler equations, and it's easier to go back to one of these equations. And wherever I see C, I'm going to multiply it instead 3 times the cost I figured out for the children's menu. Substitution again. So 3 times 8.55 is that. So I get 2A plus that. And where people make a lot of mistakes are the arithmetic side. So just practice, practice, practice. Then I'm going to do 2A is 48.95 minus 25.65. And you're going to have to close your eyes a bit on this one because this is a little bit of cheating I'm about to do. I'm just going to take this 25.95 and I'm going to subtract 48.95 and then change its sign. Boop. So I get 2a is equal to this. And then I got to divide both sides by 2. And I get that the adult menu costs this. Now, if you have time at the end of your test, how do I prove that? Get rid of these adjusted one. Go back to either of these formulas and put A up here, C over here, multiply them out, and see if it all comes out to the right side. Then do it again on this one with these prices and see if it comes out to the right side again. And if it does, you have the right thing, and if it doesn't, you made a calculation error. It's only if you have time. So the adult menu is $11.65 and the kids menu is $8.55. Substitute, it's the same thing, it's just they're making it harder and harder. Okay, simplify and then solve. So here you would expand, here you would expand, then you have an equation for simplify with all the numbers, put all the numbers on one side. Then you have an x and y equation, and then same with this one, you have an x and y, and you just solve. Here, it would be smarter to multiply this by 10 and multiply this by 10. And here's fine, but it would be smarter to multiply both sides here by 20. These are some more things. I'm going to just kind of try to touch on 14 and 15 and get to the more numerical ones. So, if I add up all these coins in 14, and since we're talking about nickels and dimes, if I add up all these nickels and dimes, there's 27 of them. We just don't know how many are in my wallet. But we know that the nickel and dimes, the number of them, times a certain amount. Let's call it X. Let's see if that'll work. So there's 27 of them. That's interesting. So I also know if I add up all the X and the Y's, they're going to add up to 215. Okay, so there's so many of the X's, the nickels and dimes, there's so many of them. So like there's 5 nickels and 10 dimes sort of thing. And they add up to that. Oh, well, I know what I'm doing here. Of course, nickels are 5. So they're 5 cents. I'm stupid here. 5 cents, which since I'm working in dollars over here, and these are all in pennies over here, it's really equal to 215. Or, if I don't change it to 215, I have to make sure that I don't multiply by 0.5, but 0.05 and 0.10, like that. So I'm going to multiply this all by 100, and I get 5 and 10 and 215. Because you're either working in pennies or dollars, so you have to make the right ratios. So now I have 2 formulas. I'm a bit stupid there. And you use the same method. We're going to multiply the top by 5. I get 5n, 5d, and this is 5 times 135. And we're just going to subtract top and bottom. 5d minus 10d is minus 5d, and 135 minus 215 is 75, 80, 90. And so, minus 90 rather. And then if you see a plus and minus, you know you made a mistake because they have to come out as plus. And then 5 goes into that 18 times, so there's 18 dimes. And if there's 18 dimes, since there's 28 totals, that means there's 9 nickels and 18 dimes. And go back and verify that I got it correct, but that's the method. So you can see it's the same method as we've been doing. And when you're in a section of a chapter, just realize, okay, whatever techniques I learned in this chapter are the ones they're going to want to see. So they operate a computer repair service. For service call, Candace charges 40, Dino charges 50. So Dino's more expensive. In addition, they each charge an hourly rate. She charges 45, so it's $40 plus this times her hour. And we'll call it Candace's, Candace's hourly rate. Dino charges a little bit less per hour, but a bigger initial charge. One day their charges for the two service cars charges were the same. So that's essentially two lines, and where do they meet? So let's look at Candace's charge. She's going to charge Candace, or Y, her total cost. Her total cost is, let's just call it Y, her total cost is equal to her initial charge plus whatever she charges per hour. Let's call it, instead of, yeah, we can call it H or X. And Dino, his total charge is going to be, his initial charge is 50, but he only charges 30 per hour, or 30X. Since these two things equal one another, we can use either subtraction or substitution, but I'm going to use substitution. When you have two equations where it's 35, y is equal to 1, and y is equal to the other, you can just make the equations equal one another. So if I bring the 40 to the right side, so if I do 35 minus 35x minus 30x is equal to 50 minus 40, I get 5x is equal to 10, so x is equal to 2. So that means they will meet when x is equal to 2. And then if I use either one of their formulas, and instead of x, I put 2, I get the y of 1, 10. So that means they're going to meet at the coordinates 2, 1, 10. And to confirm this, you can just plug their formulas in. Y is equal to 35 plus 30x, 40 plus 30x, and y is equal to 50 plus 30x. It wasn't 30x, though. They have different charge rates. 35 and 30x. This one's 35 and 30x. And where they meet. And you can always click home, and it'll make it a little bit easier. But like I said, they should meet way up at, where did I say? 2, 110. So let's just put in 2, 110 and label it and see if that's where they meet. Okay, I'm going to undo that and just make sure. Yep, that dot represents where they meet. 2, 110. And if ever you want to see the full graph, since you know you got to go up to 110, just go from 0 to 120 on your y-axis, and you know you're going to 2 on x, so you can just go to 0 to 3, and boom, it'll just kind of make it a little easier for you to see it. So there you go. That's where they meet. So when they both charge 2 hours, when their call is 2 hours long, that's when their prices are the same. So what did they charge and how long did they each work for? Well, they charged $110 and they worked for 2 hours. And if you're uncertain, go back and to the question and add up Candace's charge if she worked 2 hours, and add up Dino's, and you'll discover it comes to the same amount. And the same amount was $110. All right, moving on. So, simplify and solve. I'm not going to do all these. I'm just going to tell you how to do them. Because if you're still lost, you need to practice the stuff we just did. Multiply each thing by 3. Multiply each thing by minus 4. You should get 3x plus 3 minus 4y plus 4, because minus 4 times minus 1 is equal to that. Notice the numbers are there. They both add up to 7. Get rid of that 7 to the other side. And you get 3x minus 4y is equal to 6. Next one, same thing. 5x plus 10 plus 2y plus 6 is equal to 0. You get 5x plus 2y plus 16, so send it to the other side. So it's equal to minus 16. Where these two lines meet is the answer when they say simplify and solve. So I would multiply this bottom one by 2, so it's the same number but opposite sign. So if I multiply this bottom one by 2, I get 10x plus 4y is equal to minus 32. And then I would say, okay, I notice that my 4y and minus 4y are opposite signs, so I'm going to add everything. And I get 13x, and 6 plus minus 32 is 6 minus 32. And I get is equal to minus 26. And then when I divide, x is equal to minus 2. Then put minus 2 into the easiest equation, so minus 6 here. 12 minus 4y is equal to 12. So y is equal to minus 3. So they meet at minus 2 comma minus 3. What about this one? The easiest thing here to do is multiply the top by 10. So you get 30c plus 8d is equal to 14. Multiply the bottom by 10. You get 5c minus 4d is equal to 14. Notice that you got 8d here and 4d and minus 4d here. I'm going to multiply the bottom by 2. You get 10c minus 8d is equal to 28. Now because there's 8 and minus 8, I'm going to add them. So 30c plus 10c is 40c. 8d plus minus 8d is 0. And 14 plus 28 is 32. And I think I got it right, but I might have made an arithmetic error in there. I don't think so, though. And then you solve for c, and c is equal to 32 over 40, which is the same as, you can divide them both by 4. 8 over 10, which is 4 over 5. So that's your c, and then just plug it back into one of the equations to solve for the other one. And just throw them both the equations into Desmos to see if you got it right. And what about this one? Well, it's easier if I multiply this bottom one by a number that will get rid of 20 and 5. So if I multiply 20 times the left side and 20 times the right side, these cancel. 5 goes into 24 times. So I get on the top x minus 4y is equal to 20. And then I can just put them one atop another and use elimination. So since the x's match in number and match in sign, I'm going to use minus. So y, x's cancel. Y minus minus 4 is 5y. 40 minus 20 is that. So y is equal to 4. And then since x plus y is equal to 40, I get this. So they meet at 36 comma 4. Don't mix up your x's and your y's. And let's see. My inherited 50,000. That's a pretty tough one. It needs to make 500 leaves. Oh, that's a very hard one in that one. So I'm not going to do the achievement ones. And I'm just going to hint at what the 17, 18 should be. Or I'll at least try to figure out the formula for you. Okay, so she's inherited 50,000. She invests it, and it pays 5% per year, and the rest in a venture capital. So one is a GIC, so let's just call that X, and this is called Y. One gets multiplied by 5 over 100, the other gets multiplied by 10 over 100. Try to understand that 10% simply means 10 over 100, and it also means 0.1. So start learning your percentages fast. 25% simply means 25 over 100. Percent means per 100, which is also equal to 0.25. So learn all that. Okay, when she invests it, the total simple interest after 1 year. So she made 4,000 more than her 50,000. So first of all, when she first started, her first investment and her other investment is equal to $50,000. Second, when she put one into 5%, which is 5 over 100. Here, do it like that. And she put the other one in at 10%. She got $4,000. Now, if I multiply this bottom one by 100 to get rid of that 100, oh, by the way, that x is, it's not like that. It's actually 5 over 100 and 10y over 100, like this. Those are fractions. I'm not going to bother drawing the stick. But if I multiply by 100, I get both sides by 100. I get 5x plus 10y. Gets rid of their denominators. is equal to, and when I multiply something by 100, 2 zeros, add 2 zeros. There. Now I have two things. Okay. I'm going to multiply the top by 5 so that my 5x's match. And 5 times 50,000 is 250,000. Get rid of the dollar signs for now. And now that they match, I subtract them. I get 5 minus 10y. I get minus 5y is equal to minus 150,000. Divide both sides by 5. And I get 30,000, which means she put 30,000 in one investment, which means she put 20,000 in the other investment. Go back and see if I multiply the second investment by 10%, she would have made 3,000. And if I invest this one by, 10% is, and then if I get 5% on this one, so you just divide it by 5 and divide it by, it's 1,000. So you can see that she would have made 4,000 off of that. Little complicated. You sort of have to understand the finances on that one. This one's very hard. So you need to make 500 liters of a 30-minute acid for a customer. The lab has 25% acid solution. So let's call the acid solutions X and Y. And when we add them together, we get 500 liters. And then how many liters to make 34% solution? Ugh. So if I take 25% of X and 25 and 50% of Y, I should end up with 34%. So try to remember that's 25 over 100, this over 100, and this over 100. If I multiply everything by 100, I get 25x plus 50y is equal to 34. And there I have my two equations. I should do a couple with substitution just to show you how substitution works. So this is y is equal to minus x, 500 minus x. Woo. Which means everywhere I see y down below, I could replace it with that. And then just multiply it out. Well, that's 25x over here. 34. I think that'll work. Hang on. No, that's not going to work. 500 liters. How many liters? Yeah, actually that will work, I think. No, that won't work. I think I made a small mistake somewhere here. Maybe it'll work. I don't think it will, though. Yeah, you don't mix 1,000 liters to produce 500. So I made a small mistake somewhere. So let's go back. Yeah, let's go back to all my originals and ask myself, what's wrong with this? Oh, I see. It's got to be 34% of the final amount. So it's how many liters of this plus how many of liters of that to make 34%, 34 over 100, of a 500 milliliter thing. I think that's what's missing here. So the final 500 milliliters has to be 34%. So when I multiply all that by everything by 100, because remember this is 25%, this is 50%, I get that. I think that might be it. Let's see. And 17, like that, is it 17,000? My brain's starting to go. Yeah. So now if I have this, I might as well just use substitution to try to get it. I'm going to multiply everything by 25 up here, and I get this, 25x plus 25y is equal to 500 times 500 times 25, and that's not 20, yeah, it is 25y. 12,500. My brain's really going. So I got that. Hopefully this works. So if I subtract top and bottom, yeah, I think it'll work. I get minus 25y is equal to minus 4,500. When I divide it by that, I get 1. There's 20 left, 40, 140. Did I get it? I think I got it. $180. Yeah, my math is going. Good thing I double checked. And since x plus y must add up to 500, I know that x is equal to 320. Now, liters and y is equal to 180 liters. So then you have to go back and remember which one is x and which one is y, which one is the 25%. And since this one's the weaker one, this is probably the 25%, and this is probably the 50%. And then you just have to go make sure that's true. If I take 25% of this and add it to 50% of this, will it add up to what I'm looking for? So 25% of 320 is that 80, and 50% is 90. So actually I got it wrong. Yeah, we can always pull it up in Desmos though. So x plus y has got to equal to 500. And 0.25 of x plus 0.5 of y is equal to 0.34 times 500. And apparently they're going to meet. Where are they going to meet? So I would just... it should be an easier way to do where they meet. There it is. So they meet at 320. So it's 320 of x and 180 of y. 320 of x and 180 of y. Yeah, I got it. 320 of x and 180 of y. I just didn't do the addition right somewhere. Oh, I know what I had to do. I had to then figure out what is 34% of 500. Yeah, there we go. They should add up to 170. So that should work. Sorry, that's very confusing, and it's a tough one. It's hard to fathom. So he's traveling in 1900 from Eastern Ontario to Winnipeg. He traveled by bus to Toronto at an average speed of 60, and then flew to Winnipeg at an average speed of 700. His total traveling time was 7 hours. How many kilometers did he travel by bus? So when they mix speed like this and distance, it's really annoying. So you have to know that speed is equal to distance over time. And we know his total distance here is equal to 1900. If he went to Toronto, we also know his total time was 7 hours. So we know he does a mix of speeds to cover that distance in 7 hours. We do know that overall his average speed. But let's call his speed while driving D and his speed while flying, or time while flying, F. So if you look at velocity, which is kilometers over hour, and I multiply it by hours, we discover how many kilometers he's flown. So that means if he's flying 60, we can figure out how much his hours driving plus 700 was his speed, hours driving, times hours driving. That will give him a total distance, and we happen to know his total distance is 1900. We also know that, what else do we know? His time, his total time, is 7. Oh, wow, that's super hard. So I think we'd have to convert everything to... Oh, yes. We also know his hours driving, sorry. So we can just call hours driving D if you want. We also know his hours driving plus his hours flying. This should be flying over here. Is equal to 7. So if you want to make it easier, you can call it D, you can call drive is equal to X, and flying is equal to Y. And you can just say, well, X plus Y is equal to 7, and 60 times X plus 700 times Y is equal to a total of 1900. Because whenever you multiply speed times a time, you get a distance. And this is a very handy thing to learn. It's the triangle of knowledge, like this. And whenever you have speed, so we have this, velocity is equal to distance over time. What's the highest fraction in there? What's the numerator? Distance. Let's put it up here. And then v, t over here. Oops. V and t. And now we're going to put a line like this and a line like this. Now I have a structure that'll teach me any equation. So if I want to know distance, I multiply velocity times time. If I want to know velocity, I take distance and divide it by time. If I want to know time, I take distance and divide it by velocity. This triangle is fantastic. So if you know a formula like this, whatever's up top goes here. The other two things go in the bottom, and now you can figure out any formula from that instead of rearranging using algebra. So now I have obviously two formulas that can match, and probably the easiest thing to do is substitution. Y is equal to 7 minus X, and wherever I see Y, use 7 minus X. So you get 60x minus 700x plus 4900 is equal to 1900. So minus 640x is equal to minus 3000. I think I got that right. I might have gotten some of it wrong. Yeah, I probably got that wrong. Maybe not. Okay. Oh, well, maybe not. So according to this, x is equal to that. Whew. What the hell? Did I just grid that? Yeah, grid lines. X is equal to that, which means y is equal to 7 minus that, which is equal to this. Don't know if I got that one right. So that means he spent 2 hours. Let's see. I forget what I designated as y and x. And that's one of the problems. Oh, yeah, there we go. X is his driving, and y is his flying. So he spent 4 hours this. To confirm this, do 4.6875 times his speed. That's how much distance he traveled driving. And then 2.31 times his speed. That's how much distance he traveled. So we'll take this and we'll multiply by 700. So that took him 16.85 kilometers of the way, flying. And then I'm going to do is 4.6875 and multiply it by his car speed, which was 60. That's how much he traveled in his car. And they should both add up. When I hit MR, they should both add to 1900. And they do. So that's indeed the correct answer. So you can see these skills are useful. I'm going to skip all this stuff. Let your teacher know if you need that.